Section 2.6, solving systems of inequalities. This is really something that is new. The first part, or not new, this is something that you should know how to do from Algebra 2, even from Algebra 1. The system of linear inequalities, that's a vocabulary term. It's a set of inequalities with the same variables. We've done something like this before, so this shouldn't be terribly new. So I got an example here for you. Package delivery services add extra charges for oversized parcels or those requiring special handling. An oversized package is one in which the sum of the length and the girth, meaning distance around, exceeds 84 inches. A package requiring special handling is one that is over 60 inches long. What size packages qualify for both types of charges? So we have two types of charges. We have special handling and we have oversized. Okay, but that's not really, it is important, but it's not the most vital piece of information. So for oversized packages, it says the sum of the length and the girth exceeds 84 inches. So that's right here in the middle. So we can say the length plus the girth has to be greater than 84 inches. And then for special handling, we'll do special handling in blue. So we'll just say handling. Says the length has to be more than 60 inches. So the L has to be greater than 60. Now, how can we graph this or solve this? We're actually going to solve it by graphing. I just said that. It's going to look something like this. So I'm going to make an X and a Y axis, but I'm not going to call it X and Y because our variables are not X and Y this time. Our variables are L and G. So we'll put the length down here. Whoops. Make this length. We'll make this girth. And I'm going to go by 20s on both. 20, 40, 60, 80, 100, 120. So we'll make that. So this is 20, this is 60, this is 100, and then 20, 40, 60, 80, 100, 20. So 20, 60, 100, and then 120 would be above that. So the oversized one, L plus G, is greater than 84. If we did this by intercepts, and this is something you can really type into Desmos, you can change this to X, change this to Y, and it would do the same thing. The oversized package would cross I guess it's technically the G axis at 84, which is somewhere like right in here. And then the X axis or the L axis, again, at 84 as well. This one's going to be a dashed line because it doesn't have the or equal to part. It's strictly greater than. So that line is going to look something like this. Okay. For the handling, that's the L axis. It says L is greater than 60. Doesn't matter what the girth is. So this is going to be a vertical line at 60 going straight up. Now, we're talking greater than 60, so that's going to be this side of that line. And we're talking the length and the girth has to be greater than 84. So greater than is going to be this direction. Now, the question is, where are the arrows pointing at each other, or what areas are going to be shaded twice? That would be this area in here. So what we can say then is that all packages, actually, I'm going to abbreviate packages, PKGS, all packages in the shaded area require both charges, both types of extra charges, both charges. And for example, we could pick a number out here like this point right in here, and that would be like 100. It's kind of hard to read. 100, 100. We could say 100 inches long and 100 inches around. That would be an example of a package that would need both types of charges. It's oversized and it's too long. So we would need the special handling and the oversized charge. That would be an example of a distance or a size of package that qualifies for both types of charges. Now, that's not really the main focus of this lesson. The main focus of this lesson is the polygonal convex set. It's a new vocabulary term. What it is, it's a bounded set of all points on or inside a convex polygon graphed on a coordinate plane. I'm going to show you what this looks like here in just a second with this example. So consider the system. X is greater than or equal to 0, Y is greater than or equal to 0, and 2x plus Y is less than or equal to 4. Now, number 1 here says solve the system by graphing. I'm going to rewrite this third inequality in slope-intercept form. I'm just going to get the 2x to the other side, so it's slope-intercept form, y equals mx plus b, so negative 2x plus 4. And that's going to help us kind of graph what this is supposed to look like. So solve the system by graphing. So I'm going to do this one in blue. I'll do the third one in red since I've already written in red, and I'll do the second one in orange. So we'll start with the first one. X is greater than or equal to 0. That is a vertical line. Whoops. That's a vertical line going right here. Okay, looks like that. And it says greater than or equal to 0. Greater than, positive x values are this direction. That's this way off that line. So there's the first one. The second one says y is greater than or equal to 0. Y equals 0 is a horizontal line at the x-axis. Y equals 0. And it says it's greater than, so we're going above this line. So right now we don't have a polygon. We just have a quadrant shaded in here. It'd be the first quadrant. Now, we need to talk about the third one here. Y is less than or equal to negative 2x plus 4. So this is slope-intercept form, so we make a mark at our y-intercept of 4. And then our slope is negative 2. So we're going to go down 2 and then right 1. So we'll make another point there. And then we'll go down 2, right 1 more to make a line on the x-axis. And we can draw our line from there. Again, this is a solid line because it's got the or equal to part. And this one says less than. Y is less than. Now less than is going to be below. So that is this direction. Okay? So now, where do the shaded areas cross? The shaded areas all cross in here, in this little triangular area. Okay, so I'm going to try to color this in a little bit, in the triangular area. Now, a triangle is a polygon. So the polygonal convex set, if we look at the definition again, all points on or inside a convex polygon graphed on a coordinate plane. The polygonal convex set is this shaded area that makes up our triangle. Could be a square, could be some four-sided figure, could be a five-sided figure, six-sided, whatever. However many sides it's got, it makes a polygon. As long as the polygon doesn't do something like, this, where we go inwards, it's going to work. Now, that's what the convex part says. We can't have something that jets in, but we could have something that looks like this. That would be a convex polygon. There's lots of different types of shapes, but just think, we're probably not going to see one that isn't, so we don't have to worry about necessarily is it convex. Okay, so the polygonal convex set is the shaded area. I'll do that actually in black so we can kind of see what we're looking at. It's this area. It's the shaded area that makes the triangle. Okay. Question number 2 then says, name the coordinates of the vertices of the polygonal convex set. So what we're looking for are where do the lines intersect? We have 3 places. We have 1, we have 2, we have 3. We're looking for the vertices. Yes, I know I made another point here, but that's not a vertice. It's not where we change directions. It's part of this side. Okay, so we're not worried about that. We're worried about the 3 places where the boundary lines intersect. So it really doesn't matter what order you write them in. If we start here, this point right here, that looks like the origin, so that would be 0, 0. We have another point right here, looks like 2, 0. So 2, 0. And we have a third point way up here, looks like 1, 2, 3, 4. So that's on the y-axis, so that is going to be 0, 4. And that's all you have to do. Name the coordinates of the polygonal convex set, coordinates of the vertices of the polygonal convex set. It's 0, 0, 2, 0, 0, 4. That's it. That's all there is to it. How we're going to use this information, I'm going to show you here in just a second. But before we do that, I do need to talk about one other thing. Function notation in 2 variables. So function notation, you've seen function notation before lots of times. F of x, you've seen that before. But now we're talking 2 variables. F of x, y means the value of a function f at x and y. So you're going to be given a specific x and y value that you're going to plug in for your variables in your function. So I've got an example here. Let f of x, y equals 4x plus 3y minus 2. So now your function is written in 2 variables instead of 1. You've seen f of x equals something like 3x minus 5, where there's just 1 variable, but now we're adding a second variable. Okay, but when we're evaluating, it's no different than if I said find f of 3 up here. We just plug in 3 for x, figure out what it's equal to, and we're done. Now we're given an x and a y. We're going to plug in x and y and figure out what it's equal to. So it's really not much different than what we've been doing or what we've done in the past, but now we're just kind of applying it and extending our knowledge and our information to something that's a little bit different. So with our 2 examples here, we're using the same function, f of xy is equal to 4x plus 3y minus 2. With our 2 examples here, we're given an x and a y. All we need to do is plug that in and figure out what it's equal to. So, number 1, find f of 1, 2, or 1, 2. I'm not really sure how you want to pronounce that. It really doesn't matter to me. We're going to say we're going to go 4 times our x value, which is 1, plus 3 times our y value, which is 2, minus 2, and we're going to figure out what that's equal to. 4 times 1 is 4, 3 times 2 is 6, minus 2, 4 plus 6 is 10, minus 2 gives me 8. That's all there is to it. It's going to be f of 1, 2 is equal to, ooh, really bad parenthesis, f of 1, 2 is equal to 8. And we're going to do the same thing here with number 2. Our x value is negative 5, our y value is 0, so we're going to say 4 times negative 5 plus 3 times 0 minus 2. 4 times negative 5 would be negative 20. 3 times 0 is 0, minus 2. Negative 20 minus 2, we can say that f of negative 5, 0 is equal to negative 22. All right, so I just said that when we talked about the coordinates of the vertices that we're going to use these. Because these points right here, these coordinates of the vertices, are going to become our x and y when we're asked to find a maximum and minimum value for a two-variable function. And this kind of leads into section 7, so this might not make a whole lot of sense right now, but it will make more sense once we get into section 7 when we talk about what's called linear programming, and we'll get into that in the next video. But for right now, we're just going to be finding maximum and minimum values for a two-variable function. So when you're given a two-variable function, the function will be defined by a system of inequalities. You'll have several of them. In the example I've got here coming up, there's 4 inequalities that define a two-variable function. Once you're given the system, evaluate the function at all the vertices in the polygonal convex set. So you're going to have to graph the system, and I'm going to tell you, use your graphing calculator, use Desmos, save yourself some time. We're not looking to see if you can graph the line correctly. We're looking to see if we can find the points of intersection, find our vertices in our polygon to be able to evaluate the function at those vertices, okay? And that leads into the vertex theorem. The vertex theorem says the maximum or minimum value of a function, a two-variable function, f of xy equals ax plus by plus c. It doesn't really matter what those a, b, and c are. It's just going to be like these two, 4, 3, and negative 2. That would be an example. But it says the maximum and minimum value of that two-variable function on a polygonal convex set occurs at the vertex or at a vertex of the polygonal boundary. Okay, so we don't have to worry about testing any of the points inside of our shaded area if we were to, or when we graph this. We're looking at the points of intersection. We're looking at the vertices of our polygon to figure out which one maximizes or minimizes the situation that we're looking for. So let's do an example here. Find the maximum and minimum values of f of xy equals x minus y plus 2 for the polygonal convex set determined by the system of inequalities. So I'm going to give you the system. You've got 4 inequalities here that define this function. Okay, this is the situation that we're working with. These are the parameters that we have to work in. We have to figure out the vertices first. Okay, if you're going to do this by hand, what I would recommend that you do is graph each of these, and I would put them in slope-intercept form. So if we were going to put these in slope-intercept form, this one's going to be y is less than or equal to negative 1/4 x plus 3. The next one would be, after we do this, it's going to be y is less than or equal to. This would be one where your inequality sign changes because you'd have to divide by a negative. Just keep that in the back of your mind. 3/2 x plus 3. The next one we'll do in purple becomes y is greater than or equal to negative x minus 2. That one's pretty easy. And the last one I'll do in orange. This is another one where we have to flip the sign. Y is greater than or equal to positive 3x minus 10. What I've done, I already did this on Desmos and I took a screenshot of it. If you want to take a minute and graph these by hand, feel free, or type it into Desmos or your calculator by yourself or on your own time. Feel free to stop the video right here and do that. Otherwise, I'm going to scroll down here, or scroll up, I guess. Scroll down, I think it is. And you can kind of sketch the picture. Here's what the picture looks like. After you graph those 4 inequalities, you get something that looks like this. Now, the colors aren't exactly the same from my writing to this picture. This is what Desmos gave me, but the shape and the quadruple shaded area is the same. Okay, so our polygon looks like this. We have this side, we have this side. That's a really bad line. We have this side, so it makes a kind of a kite. Not technically a kite because we don't fit the right dimensions or the right parameters for these side lengths, but it's got the shape of a kite. That is our polygon. And what we need to figure out are what are these 4 vertices. That's what we need to find out first. Okay. If you use Desmos, if you use your graphing calculator, you can find these pretty easily. This point right here is 4, 2. This one right here is 0, 3. This one over here is -2. I'm actually going to write this below it. -2, 0. And this point over here is 2, -4. And those points are important. Now, if we had context, I think it would make more sense what these points represent. But right now, we don't have any context. So right now, we just need to find the maximum or minimum value of our original function, which is this one right here. Okay? F of xy equals x minus y plus 2. So I'm going to rewrite that. F of xy is equal to x minus y plus 2. And what we're going to do is we're going to test these 4 points, these 4 vertices, to see which one gives us the highest value and which one gives us the lowest value, because the highest value is the maximum value, the lowest value is going to be the minimum value. Okay, so let's just start plugging right along. Let's start with -2, 0. So we're going to say, I'm going to do this in green. So we'll say f of -2, 0 is equal to -2 minus 0 plus 2. That actually works out really well. That's 0. So we'll say f of -2, 0 is equal to 0. I'll just do -2 or 2, -4 while I've got it on the screen here. F of 2, -4. So x value is 2 minus my y value of -4 plus 2. This eventually all becomes addition. 2 plus 4 is 6 plus 2 is 8. Okay. One of the other points, let's see if we go back, looks like 4, 2. So f of 4, 2 becomes our x value is 4 minus our y value of 2 plus 2. These two cancel each other out, so we're just left with 4. And then the last point way up at the top was 0, 3. So we're going to do f of 0, 3. X value is 0 minus our y value of 3 plus 1, not plus 1, plus 2. Plus 2 equals 0 minus 3 is -3, plus 2 is -1. So the question said, let me scroll way back to the top, find the maximum and minimum values. Well, the maximum value looks like is going to be 8. So the max is right there. The minimum value, the smallest one there, is -1. So that are your maximums and minimums. It's not the ordered pair, it's the actual number. It's 8 and -1.